Can you imagine trying to create beautiful, complex art on a computer with less memory than, say, a modern digital watch? Well, back in the 1980s, that wasn't some kind of crazy challenge. It was the absolute cutting edge. Today, we're going to dive into the creative powerhouse that made it all possible on the legendary Commodore 64, a little something called Simon's Basic.
So what was Simon's Basic? Well, it was this cartridge that you'd literally just plug into your C64, and it gave programmers a supercharged set of new tools. We're going to unpack its graphics arsenal, 5 key commands that really transformed simple coding into a true visual art form. Think of it as the ultimate creative toolbox for 8-bit artists. All right, let's open up this toolbox. First up are the commands that let programmers finally break free from all those clunky, blocky shapes and start thinking with smooth, elegant lines. Okay, so the standard C64 could draw a full circle, sure, but what if you only needed a piece of one, an arc? Well, that's where the arc command came in. It gave you the power to draw a perfect, specific segment of a circle or an ellipse. And trust me, that was a huge leap forward. And what's really cool here is the sheer level of control this gave you. You could literally tell the computer the exact start and end angle for your curve, from 0 to 360 degrees. Want a perfect 90-degree arc? No problem. A tiny sliver at 270 degrees? Easy. This was absolute precision. And check this out. This shows you just how versatile one single command could be. On the left, you're in high-resolution mode, and you get these sharp, really intricate patterns. But on the right, in multicolor mode, you can create these vibrant layered ellipses. It's the same tool, but leading to completely different artistic results. Now let's talk about ARC's perfect partner, ANGL. While ARC was busy drawing the outside curve, ANGL was all about drawing lines from the center outwards. You can think of it as the go-to tool for creating things like starbursts or the spokes on a wheel, really any kind of complex radial pattern. And just look what happens when you pop it inside a simple programming loop. By just drawing lines that expand outwards and then pull back inwards, you could generate this stunning mirror effects. I mean, these mesmerizing patterns could be created with just a few elegant lines of code. It's fantastic. All right, on to our next tool. This one solves one of the biggest challenges of the entire 8-bit era, managing that incredibly limited memory. Back then, every single byte counted. The paint command is, it's beautifully simple. You draw a closed shape, you pick a point inside it, and bam, paint flood fills the entire area with color. It's basically the digital equivalent of a paint bucket tool. But its real genius wasn't just about coloring things in. And this right here, this was a revolutionary memory-saving hack. Instead of storing huge image files, game developers could just draw simple outlines and then fill them with color right when you were playing. This meant they could pack in way more graphics without eating up that precious RAM. And you can see just how versatile it was. You could use it for something super precise, like filling only the area where 2 circles overlap. Or you could get really creative and make these beautiful, complex mosaics just by randomly filling in sections of different shapes. So far, we've drawn curves and we've filled in shapes. But what if you wanted to create something completely custom, something nobody had ever seen before? For that, we turned to the dynamic duo, the 2 commands that offered nearly limitless creative freedom. So meet, draw, and rot. Now these 2 commands had to be used together, always. Draw was for defining any shape you could possibly imagine using just a string of numbers. And then rot would take that shape and bring it to life by rotating it and resizing it. The way draw worked was kind of like programming a digital paintbrush. You'd feed it a string of numbers that told it where to move and when to draw. So this example string here is just a simple set of instructions: draw right for a bit, then draw up, then draw left, then draw down. And boom, you've got a perfect square. So once you had your shape from draw, rope took over. You could spin that shape around in 45-degree steps, and you could scale its size anywhere from normal all the way up to 255 times bigger. This is where your custom shape really got its dynamism. And here's the wild part. You'd think draw is the main command here, right? But it was completely, totally dependent on its partner. If you didn't set a rotate command first, even one that did nothing, no rotation, no scaling, the draw command would simply refuse to work. They were a true team. And the results you could get were just incredible. On the left, you see a transformation loop where a square is drawn over and over, each time rotated 45 degrees and scaled up. And on the right, a custom rectangle travels across the screen, leaving behind this vibrant, animated trail of color. This was true geometric magic.
So there you have it. We've just assembled a complete creative toolbox that turned a simple home computer into a surprisingly powerful canvas for art.
So, to recap, we had our graphics arsenal, arc for the curves, ANGL for all those radial patterns, paint for super efficient color, and of course, the powerhouse duo of draw and rot for creating pretty much any custom shape you could dream up. With just these 5 commands, programmers and artists weren't just writing code anymore. They were given a new language for digital expression, one that allowed them to achieve these unexpected and beautiful visual effects on a humble 8-bit machine. And that kind of leaves us with a final thought to chew on. The artists using Simon's Basic didn't have unlimited power. What they had were a few clever tools and some very tight constraints. So it really makes you wonder, when our technology has limits, does it actually force us to become more creative?